So we're going to look at factoring in this video. I'm going to just kind of hit this kind of quickly. I'm not going to do multiple of each one, but I want to give you an idea so you can kind of see the difference between the different types of factoring. In the last video, I talked about how to find the GCF. So that's related to this as well. You can factor out the GCF. I'm going to start with factoring by grouping. The thing with factoring by grouping is generally you will know when to factor by grouping when there are 4 terms. So if you see that there are 4 terms, you're probably going to want to factor by grouping. The problem that you're faced with may also sometimes tell you to factor by grouping, so you'll know what to do. But with factor by grouping, there will be 4 terms, and what you're going to want to do is literally group it into 2 different sets. And then we're going to factor out the GCF of both of these. So I mentioned, I talked about how to find the GCF in the previous video. So we're going to factor out the GCF. So we're going to basically, opposite of distributive property, instead of distributing something over the binomial, we're going to factor something out. So the GCF of y cubed and y squared would be y squared. So we're going to factor that out. And if we divide that out, y squared times what equals y cubed? That would be y. Again, think of this as the reverse of the distributive property. If you factor y squared out of y squared, you get 1. So that's just minus 1. It was a negative, so I want to be careful with that. And then notice that this one, there's nothing that I can factor out. There is no GCF there, so I'm just going to leave it. Now with factoring by grouping, if it will work, this will always happen, where this that you're left with when you factor out the GCF is always going to be the same. So that is now the greatest common factor of this term and this term. Notice they're separated by a plus, so you have a term here and a term here. The GCF, the common factor, is this y minus 1. So I'm going to bring that out. So I'm going to kind of do the same thing, but again with what I'm left with. So I'm going to bring that y minus 1 out front. And if I take y minus 1 out of this, I'm left with y squared. I'm going to bring down that plus. And then if I divide y minus 1 out of this, I'm left with 1. It divides in 1 time. So you can kind of see this. If you took this and multiplied by y squared, you'd get this. If you took y minus 1 and multiplied by 1, you'd get this. You can also go back and use the FOIL method, or multiplying, to see that you would get what you started with. So that is the best part about factoring, is when you're done, you can actually check your work by just multiplying it back out, and you should get what you started with. So that's a really nice thing about factoring. All right, I'm going to show you another example. All right, we've got, this one's going to be a little bit harder because we have a negative to deal with, but I'll explain this. All right, now we're going to group. There are 4 terms, we're going to group it. I'm going to go group these. Now I'm going to hesitate here right there. So if I group this, then I just changed the value, because remember when we were talking about subtracting polynomials, you have to distribute that negative. So if I throw in parentheses right here, that would be like a minus 3x minus 12. So to adjust, to fix that, what I'm going to do, because this is only minus 3x, 3x is the only thing I'm subtracting, this is a positive 12. I'm going to make this plus a negative first, and then group, so that that's a positive, so that you don't have to worry about the distributing there. So I would always do that. That middle sign when you're grouping is a minus. I would change it to plus and negative before you group, so that you make sure that this is still the same as what you started with, because if you throw those in there with that negative and then distribute that negative, it will be a different problem than what you started with, so you got to be careful there. But from there, I'm going to do exactly what we did in the previous problem, is factor out that GCF. Greatest common factor of 2 and 8 is 2. GCF of x cubed and x squared is x squared. So I'm going to factor that out, so divide it out of this term. If I divide it out of here, I'm left with x. And you can check yourself, 2x squared times x would be 2x cubed. And then minus 2x squared times what would give me this? It would be 4. So 2x squared times 4 would give me negative 8x squared. And then here, what I see, I have a common factor of 3, but I also see that this first one is a negative. So to make it pretty, I'm going to pull out the negative 3. So, and you'll kind of see why I'm doing this too. So I'm going to make that a minus 3 that I'm pulling out. And if I divide that out, that'll give me a positive x and then a negative 4. So minus 3 times negative 4 gives you that positive 12. Now notice, again, with factoring by grouping, these have to be the same. So they are. If they don't end up that way, then you know either grouping doesn't work or you've done something wrong. So just be careful there, especially with those negatives. Like I said, with this whole situation here, you want to bring out that negative, and when you divide that out, this will be negative. All right, so now this x minus 4 is my GCF, so I'm going to factor that out, bring it out front. So x minus 4. And then if I take that out of this term, I'm going to be left with 2x squared. And if I divide it out of this term, I'm going to be left with minus 3. And that's it. All right, so that's factoring by grouping. All right, so we're going to look at factoring trinomials. Now, we're going to do specifically trinomials with leading coefficient of 1. When there's a leading coefficient other than 1, and when I say leading coefficient, I mean of the x squared or the a squared or whatever the degree 2 term is. If it's not 1, then we have to kind of do a little bit more of trial and error and finagling with that. But for the purposes of this video, we're just going to look at factoring the leading coefficient 1. So basically, when you have a trinomial, you're going to factor into the product of two binomials, and these two numbers are going to, they're going to multiply, I guess I could have said that, multiply to equal 6 and add up to 5. So these two terms, so the first two will always multiply to be this. So in this case, it will be a times a. It will give you a squared. So you kind of think of the reverse of the FOIL method, or the reverse of the distributing, like we talked about. So a times a will give me a squared. These last two are going to multiply to be 6, but also you're going to have that a times this and this times this. That inner and outer are going to add up to be that a term. So what multiplies to be 6 and adds up to be 5? It would be 3 and 2. So a plus 3, a plus 2. And you can check this by doing the FOIL method. A times a is a squared. A times 2 is 2a. 3 times a is 3a. And 3 times 2 is 6. And then combine those two terms. You've got a squared plus 5a plus 6. And that is what we started with. So you can check your work really easily on these, which is really nice. So that is the idea with this, is the first two terms will multiply to be this, the last two terms will multiply to be this, and that's always true with factoring trinomials. But when that leading coefficient is 1, these two will also add up to be that middle coefficient, which is really nice. Okay, so another example of that, I'm going to actually show you one where this is a negative. So if this is a negative, that means that's going to kind of clue you into one of these is going to have to be positive, one will have to be negative, because a negative times a positive equals a negative. Also, again, these first two terms must equal x squared, so x times x. And then these are going to multiply to be negative 4 and add up to be 3. So what would multiply to be a negative 4 and add up to be 3? And that would be a positive 4 and a, whoops, I said negative and I wrote it positive, but they should have opposite signs. So a positive 4 and a negative 1. 4 times negative 1 is negative 4. 4 plus negative 1 is positive 3. So there's an example of that. Here's another example. It could be reverse signs too. Like if this was a negative, you have to consider that as well. But here's one more example before moving on. All right, on this one, notice that again, x and x make x squared when multiplied. These last two terms have to multiply to be a positive 10, but also notice that you've got a negative 7. They have to add up to be a negative 7. So if you think about what multiplies to be a positive but adds up to be a negative, that would be two negatives. A negative times a negative will give you a positive. So I already know straight away from those signs that that has to be a negative and then a negative. So what multiplies to be 10 and adds up to be 7? 5 and 10. 5 and 2, sorry. So 5 and 2. Negative 5 times negative 2 is positive 10. Negative 5 plus negative 2 is a negative 7. And that's it. All right, so that's factoring trinomials. Okay, difference of squares. All following a formula, if you see a problem in this form, something squared minus something squared, it will always factor to be that something plus that other something times that something minus that something. So in this case, a squared minus b squared is equal to a plus b times a minus b. Simple example of this, if you see x squared minus 4, it is just going to be, what do you square to get x squared? X. And what do you square to get 4? 2. It'll be x plus 2 times x minus 2. If you see 25y squared minus 16, what do you square to get 25y squared? 5y. What do you square to get 16? 4. So it will be 5y plus 4 times 5y minus 4. And that's it. And you'll kind of see that pattern. These are actually one of my favorites because you can kind of just look at it and tell, especially if you know those perfect squares, like you know that 25 is 5 squared and 16 is 4 squared. So if you know those perfect squares, these are pretty easy to recognize and work out. It is possible too that you might have to factor something out first. So let's say that you had 8x squared minus 50. Now this does not look like a difference of squares. It's not, as is, because neither 8 nor 50 are perfect squares. But when we talk about that GCF, the first thing that you always want to do with the problem, if there is a greatest common factor, factor that out first and make it simpler. So in this case, there is a 2 that goes into both of these. So I'm going to factor out a 2, and that's going to leave me with 4x squared minus 25. And then look, that now is a difference of squares. So I don't want to lose that 2, but now I can write this as a difference of squares using this formula, 2x squared, so I'm sorry, 2x plus 5 and 2x minus 5. Using that formula. Now when I'm factoring, when I multiply this back out, I want it to equal what I started with. So I'm not getting rid of that 2. That stays as part of, I factored that out as part of that factorization. So just make sure that you know, if you factor out a GCF, you leave that in the problem. Okay, so that's difference of squares. And then the last 2 that we're going to look at are sum and difference of cubes. Alright, so the first one, sum, this is another formula. This one's not, it's easy to recognize, it's not as easy to use though. You have to play with it a little bit more, but this is just a plus b times a squared minus ab plus b squared. Notice this is plus, this changes. So this is a negative here. When we have difference of cubes, this is going to be minus. So the first binomial when you're factoring keeps that sign, but then this next one is going to be plus. And if you want a fun little activity, you can actually prove this. You can go through and multiply this out, and you will be able to cancel some middle terms and end up with this a cubed minus b cubed. So the idea here is similar to the difference of squares, where you identify what it is that you're squaring, and in this case, what it is that you're cubing, and then you just plug into the formula. This one's just a little bit trickier to use because you have more going on with the formula. I'm going to show you 3 examples. This is a fairly simple one, x cubed minus 64. The first thing that you would have to do is recognize that these are perfect cubes. This is a cube, this is a cube. By the way, cube, what that means is that 4 to the 3rd power equals 64, so there's something to the 3rd power that equals that number evenly. So in this case, our a, for the purposes of the formula, your a would be what you're cubing to get x cubed, which would be x, and your b would be what you're cubing to get 64, which would be 4. It's 4 times 4 times 4 is 64. And then once I have my a and my b, it's just plug into the formula. This is a difference, so we're using this formula. So it would be a minus b, in this case x minus 4. A squared would be x squared, plus a times b would be x times 4, or 4x, and then plus the b squared, which in this case would be 4 squared, or 16. So that's what we just identify the a and identify the b, what it is that you're cubing to get this, and then just plug directly into that formula. I'm going to erase this, but leave the rest of that up there. get another problem in here. All right, in this case, what am I cubing to get 8y cubed? Would be 2y. 2y. 2 cubed equals 8, and y cubed is the y cubed. And then b, what am I cubing to get 125? That would be 5. And then I'm just going to plug this directly into this formula. Again, this is a sum, so I'm plugging it in here. So a plus b would be 2y plus 5. That's the easy part. Now I mentioned, I think this might have been the last video that I mentioned this in, but when you're plugging in, I would plug in parentheses, especially if there's more than one factor there, because this next part is x squared, which x in this case is 2y together. It's not just the 2, it's not just the y, it's 2y. So we need to square that whole thing, 2y. So I'm going to put that in parentheses and put that square out there. If you can skip that step, that's fine if you recognize that that's going to be 4y squared, but just be careful there. And then plus, I'm losing my spot. Oh, we're doing the sum of cubes, so that's actually going to be a minus. A times b, so 2y times 5 is going to be 10y, and then b squared is going to be the 5 squared, which is 25. And then, of course, we want to simplify that, so that would be 4y squared minus 10y plus 25. So you just want to be careful with the, again, this one, when you're plugging in into that square, when you've got that a squared there, you're squaring that whole thing, so you want to be careful there. All right, just another note, this is the last of these, but if you have a problem that, even with these, like if you see something that doesn't look like a perfect cube, but this is a cube, the variables are cubes, look to see if there's a GCF. If it doesn't immediately look factorable to you using one of these methods that we're talking about, there might be a greatest common factor. And if you factor that out, then you might be left with something that does match one of these, the difference of cubes, sum of cubes, etc. All right, so that is it for this one.